So hi guys, welcome to the Studentship YouTube channel. Today in our chemistry series, we'll be discussing salt. So please, while you are here, like this video, subscribe to this channel, and also share this video with your friends also. Salts are like offsprings of acids and bases because one of the major ways to get salt is when you combine acid with a base. So it doesn't mean that you cannot get salt by other means, but a major way to get salt is combining acids and bases. So if you've not watched the video on acid and bases, please check the link in this video to see the tutorial on acid and bases, and make sure you watch it for you to synchronize with this video also. Nice. So in our day-to-day activities, we usually have salt, the table salt and the kitchen salt that we have in our home, okay, which is basically sodium chloride salt. Nice. So what are these salts? How do you define a salt? How do you explain a salt? Nice. So salt is one of the major products of neutralization reaction. Salt is one of the major products of neutralization reaction. So what do I mean here? Neutralization reaction, which is when an acid and a base combine to give salt plus water. So salt is one of the products of this reaction. Nice. But this definition is not so encompassing. It's not so encompassing. Okay. The definition of salt is when the hydrogen ion of acid is being replaced by a metallic or ammonium ions. You know, in our video on acid, I told you guys that acids, they ionize to produce hydrogen ion as the only positive ion. So HCl will ionize to get hydrogen ion here plus chloride ion. Okay, nice. So when you replace this hydrogen ion by a metallic ion or by ammonium ion, you get a salt. You get a salt. For example, metallic ion that's ions of metals like sodium or potassium. Okay, nice. So when you replace hydrogen ion by a metallic ion, you form a salt. Okay, so if you replace this hydrogen ion here with, say, Na, we're going to form NaCl, which is sodium chloride, the normal table salt that we all know. So the definition of a salt is when you replace a hydrogen ion with a metallic ion or ammonium ion. We have types of salts. So salts can be simple or complex. You have the simple salt or the complex salt. Nice. So the encompassing definition of salt is salts are compounds that are being formed when the ionizable hydrogen ion is replaced by a metallic ion or ammonium ion. Salts are compounds that are found when the ionizable hydrogen ion of acid is replaced by a metallic ion or ammonium ion. So like I said, when you replace the hydrogen ion by a metallic ion or ammonium ion, you form salt. Nice. So we have types of salts. So basically, you have two types of salts. You have the simple salts, and the complex salts. So a salt can be simple or complex. Nice. So these simple salts now have subunits. You have the normal salts, you have the acidic salts, you have the basic salts, and you have the double salts. Okay, so the simple salts are four of these, while complex salt is just complex salt. Okay, so we'll be discussing this now in the, one by one. So what are normal salts? What are normal salts? Nice. So you get normal salts when the whole hydrogen ion is completely replaced. For example, when I like using HCl as an example. So HCl give you hydrogen ion plus chloride ion. Nice. So when this hydrogen ion is completely replaced by a metallic ion or an ammonium ion, you form a normal salt. When the whole hydrogen ion in solution is completely replaced by a metallic ion or ammonium ion, you form normal salt. So a normal salt is neither acidic or basic. A normal salt is just normal. It's neither acidic or basic because all the whole hydrogen ion is completely replaced by a metallic or ammonium ion. Example, you have HCl plus sodium hydroxide will give you sodium chloride plus H plus water. Okay, nice. In this reaction, the whole hydrogen ion was completely replaced by a metallic ion here. Nice. So that's for normal salts. Okay, so that's for normal salts. Nice. So let's talk about the acidic salts. The acidic salts. So in acidic salts, okay, the salt is still acidic. It is a salt. Yes, a normal salt has been formed, but it is still acidic. Why is it still acidic? Okay, this salt is acidic because the hydrogen ion on that salt is not completely replaced. The hydrogen ion of that particular salt is not completely or totally replaced. Okay, nice. So basically, acidic salts tends to occur in dibasic salts. Nice. In our tutorial on acidity, I told you about basicity, which is the number of replaceable hydrogen ion. Nice. So a dibasic salt has two hydrogen ions to be replaced. A tribasic has three hydrogen ions to replace. Nice. So, but a monobasic just has one. For example of monobasic is HCl. Here is H2SO4. Is an example of dibasic salt. Nice. Nice. So, in acidic salt, if you don't totally replace this hydrogen ion with a metallic ion or ammonium ion, you form acidic salt because that salt will still have some hydrogen ion that can still be replaced. What do I mean here? For example, H2SO4, okay? H2SO4 combines with potassium hydroxide. They're going to form, okay, this is the product now. So this is a salt and this is a water. Okay, this is an acid, this is a base. Nice. So this is an acidic salt because when this acid combine with a base, when this acid combined with a base, the the hydrogen ion here was not completely replaced. The hydrogen ion of this acid was not completely replaced. So this is part of the hydrogen ion here. So it means that this salt still has a acidic property. Okay, this salt still has a hydrogen ion that is still in the salt. Okay, that's what makes this salt acidic salt, because this acidic salt it can turn a blue litmus to red. Okay, and also it can combine with a base to form another salt. So this is an example of acidic salt. Okay, in acidic salt, always remember that the whole hydrogen ion is not completely replaced. It is partially replaced. Okay, and salt that can and salt and acidic salt can be gotten from dibasic or tribasic acids. Dibasic or tribasic acid, because normally monobasic acid is completely replaced. Okay, so dibasic acid, if is which is two. Okay, if you replace one, Okay, then one is remaining, and that one will now be found in the substance of the acidic salt. Nice. So diabasic acid give rise to this acidic salt. Let's talk about the basic salts. Okay, nice. So in basic salt is a salt that has more of base properties. Okay, it has more of base than an acid. Okay, and basic salts they contain more hydroxide than the halogen ion. Okay, and also because it has more base properties, it means that it can turn a red litmus to blue. Okay, and a basic salt can still react with an acid to form another salt. Are you following? Nice. So it's like the opposite of acidic salt. This one is more acidic, while this one is more basic. Nice. So a good equation for a basic salt is below. So calcium hydroxide will react with HCl to form calcium. Nice. So when calcium hydroxide reacts with a HCl, it's going to form these salts, okay? Nice, and water. So this salt is a basic salt because it still has this hydroxide ion in it, this OH. Nice. And because I have this OH, it exhibits base properties. That means it can turn a red litmus to blue. Nice. So this is a clear indication of basic salts. Nice. So let's talk about the last part of the simple salt, which is the double salt. The double salt. Right. So in double salt, two simple salts combine to form a double salt. Okay. Basically, in double salt, two simple salts combine to form a double salt. Nice. And this double salt, they has a general formula of M plus M plus SO4 dot. Right. So the general formula for double salt is this. Okay. So now basically it's being formed by two cations and one anion. Okay. Nice. So you have M plus here, which can be sodium or potassium. Okay. And this M plus plus mean that they are basically trivalent this way. Trivalent. That's three ions, and they basically belong to major transition metals like aluminium. Nice. And this is now the also sulfate ion. Okay. And basically they have water of crystallization, which is nice. So this is general formula for double salt. Nice. So in double salt, two simple salts combine, and if you crystallize them out, the product, okay, still retain the properties of the individual salts. Nice. So once you crystallize them out to form crystal, that's why I have water of crystallization here. Nice. So once you crystallize them out, the product has properties which are similar to those of individual salts. So that's it for the double salt. Nice. So in complex salts, which is the other group of salts, like I told you, have the simple and the complex salt. So we are done with the simple salt. Nice. So in complex salts, two salts combine to form a complex ion. Okay, nice. So the product of complex salt is different. It shows a total different properties from the individual salt. It shows a total different properties from the individual salt. Nice. So in complex salt, the product forms a complex ion. Nice. And this complex ion basically has a metallic ion here, okay, as the core, and it now has electron donors, okay, which are the ligands. Nice. So basically, in complex salt forms a complex ion, like I told you before. And this complex ion, you can denote them by a bracket this way, okay, with N plus or N minus, depending whether it's cationic or anionic. Nice. So this N stands for multiple. N can be 1, N can be 2, 3, 4, 5, 6, etc. Okay, so this N stands for numbers. Nice. It's nice. So a major example of this, a common example of this is for this complex ion is copper. We have ammonia ligands. Okay, so this is an example of the formula I just gave you. Okay, nice. So these are the ligands, okay, formed by major metallic ion core. Okay, and these ligands fuse to it now. So this is a complex ion, okay, which is being formed in complex salts. And this complex ion, which is the product of this complex salts, okay, the product is different from the properties are different from that of the constituent elements. Nice. So a good example of complex salt is tetraamine copper 2 ion. So this is a good example of a complex salt, and I've given you the diagram earlier. Nice. So that's it for the type of salt. So I've done the simple salt and I've done the complex salt. Nice. So what are the uses of these salts? Okay. So this salt now, of what benefits are they to man? What can you use this salt to do? Nice. So the uses of salts are so numerous. So we'll just take few of them. Nice. So this salt is used in agrochemicals as fertilizers. Agrochemicals as fertilizers. Example, you have the copper sulfate. Okay, nice. So this copper sulfate is used as a major fertilizers in agrochemicals. Also, you can use salt, okay, for as antacids. That's in medicals, okay, as antacids. Example is sodium thiocarbonate, okay, as antacids. Also, you can use this salt in preservation processes. That's the normal sodium chloride. You can use to preserve meat and some fishes. Okay, nice. You can use this salt in treatment of water plants. Example, the alum, that's double salt that we just discussed earlier. Okay, you can also use this salt for plaster of Paris, that's POP. POP. Okay, that's the normal cast you see in patients with fractured limbs. Okay, so this POP is made up of majorly calcium sulfate, okay, as POP. Also, you can use this salt, like example, the potassium triazonitrates, in making gunpowders. Okay, using gunpowders. Okay, you also use the zinc chloride. Zinc chloride is useful in refineries. Nice. So the use of salt, they are so numerous, but we're going to stop here for today. Okay, nice. So let's talk about how to prepare the salt. How are salts being prepared? Okay, does it fall from heaven, or I don't know, like how do you prepare this salt? Okay, nice. So for you to prepare salt, you have to follow two basic principles, and those principles is that this preparation is dependent on the solubility of those salts and reaction with heat. Okay, nice. So whether the salt is compatible with heat, or whether the salt is soluble or not soluble. So these two major factors determines how you prepare your salts. Nice. So based on solubility, it implies that salt can be soluble or insoluble. Right. So we're talking about how to prepare this basis of like soluble salt and insoluble salt. Okay. Nice. So We'll go with the insoluble salt first because that's a bit easier. Okay, nice. So how do we prepare insoluble salts? Insoluble salts. Nice. So insoluble salts are prepared first of all by a process called the double decomposition. Double decomposition. Okay, nice. So here, what happens here is that you combine two soluble compounds. You combine two soluble compounds, okay, to give a soluble and an insoluble compound. Nice. So you combine two soluble compounds. Those soluble compounds can be salts. Okay. So when you combine two of them, you get a resultant of what? A soluble and an insoluble salt. Nice. So you get soluble plus soluble to give insoluble plus soluble. Okay, nice. The principle here lies that once you form a soluble and an insoluble salt as your product, you can now get two of them. You can now get the insoluble salt by filtration because this is an aqueous solution. Nice. So once you filter, the insoluble salt will be on the filter paper while the soluble salt will form the filtrate. So a good example of this double decomposition is when you combine AgNO3 plus sodium chloride. It's going to give you silver chloride plus sodium trioxonitrate. Nice, nice. So this is our insoluble. This is our soluble. Nice. So here you use a soluble and soluble compounds. Okay, nice. So these two are soluble. You combine two of them together and you precipitate an insoluble salt. So this is called a double decomposition process. Nice. Because once you have gotten an insoluble and a soluble salt, you can just do your normal filtration. Okay, so once you do your filtration, this soluble will become your filtrate, while this insoluble salt will be on the filter paper. So by so doing, you have gotten your insoluble salt. Nice. Another way of forming insoluble salts is by combination of constituent elements. Combination of constituent elements. Nice. So this step is useful if you want to form salts, if you want to form binary salts that is salts that are formed by two major elements. Binary salts. Okay, nice. So okay, that's two elements forms them. So you just combine the constituent elements. So for example, iron plus sulfur, we form iron sulfide, which is a salt. Okay, so this one is also an easy step. Just combination of the constituent elements, okay, to form this kind of binary salt. So when you combine the two component elements, you form a binary salt. Nice. So that's it for these soluble salts. Okay, so let's talk about the soluble salts. How do you get a soluble salt? And okay, basically, you know that for a salt to be soluble, that means it means that the salt can dissolve in water. The salt is dissolvable. So basically means that these insoluble salts, they cannot dissolve in water. So that was basically the explanation of soluble and insoluble salts. Okay, insoluble salts cannot dissolve in water. Okay, they are not dissolvable. While soluble salts, they can dissolve in water. Nice. So let's talk about the soluble salts now. Soluble salts. How do you form soluble salts? Nice. So a method way of forming soluble salt is the neutralization reaction. Nice. That's action of an acid plus a base or alkali. Okay, nice. So when you react an acid with a base and alkali, you form soluble salt. Okay, for example, HCl plus sodium hydroxide will give you a normal table salt plus water. Okay, so this is just a neutralization reaction. So acid combines with a base to form a salt and water. So this salt is soluble. Okay, so this is one of the major ways of forming soluble salts. Nice. You can also form soluble salts by when you react an acid with a metal. When you combine an acid with a metal, okay, those metals are capable of displacing hydrogen ion. So once you do this combination, you can form also soluble salt. Okay, action of acids on metals. Okay, nice. So here, for example, you have magnesium combining with tetraoxosulfate acid. Okay, you're going to form magnesium sulfate plus hydrogen gas. Okay, so this salt is soluble also. The salt is soluble also. Nice. So another way of forming soluble salts is when you combine an acid with an insoluble base. Are you following? Yes. So when you combine an acid with an insoluble base plus insoluble base, SO4 plus CO will give you a copper sulfate. Okay, so this is a soluble salt also. When you combine an acid with an insoluble base, you form an insoluble salt. Okay. Also, you get soluble salt when you react acids with triazocarbonate. Okay. When you react acids with trioxocarbonate, you get soluble salt also. So an equation to justify this is when say HCl react with copper carbonate, we're going to form copper. Okay, when you react with H2SO4, we're going to form copper sulfate plus H2O plus carbon dioxide. Okay, so our copper sulfate here is still a soluble salt. Nice. So these are the processes that you can use to form soluble salts. Nice. So like I told you, these soluble salts are salt that can dissolve in water or in aqueous solution. So how do you get the salt out? Okay, like in insoluble salt, you get it out by what? Filtration. Okay, because it is insoluble, so you can get it on a filter paper. Nice. Well, insoluble salt now, how do you get them out? How do you get a pure soluble salt once you have prepared them? Nice. So you can get the soluble salt by two major ways. Okay, by heating to dryness or by crystallization. Okay, nice. So you heat the salt to dryness. Okay, so once you heat the salt, heat the solution, and the water evaporates, you can now get your pure salt. Nice. But there are some salts that you don't heat to dryness because those salts they decompose on heating. Those soluble salts they decompose on heating. So how do you now recover them from the solution? You form crystals of them. That's by process called crystallization. Okay, nice. So you induce crystallization or you use heat dryness to get your soluble salt out from solutions. Nice. So let's give examples of all these soluble and insoluble salts. Okay, the soluble and insoluble salts. How do you know two of them, and how do you get to differentiate two of them? Okay, nice. So I'm going to give you a table. I'll help you to remember that. So you have soluble here, you have insoluble here. Okay, nice. So all sodium, potassium, and ammonium salts they are soluble. So that should so always remember that. Okay, all sodium, potassium, and ammonium salts they are soluble. So anywhere you see a sodium or a potassium and ammonium salt, always know that it's soluble. This will help you in MCQ questions. Okay, so sodium, potassium, and ammonium salts are soluble. All of them are soluble. Okay, nice. Also, All chlorides are soluble. All chloride salts are soluble except that of lead, silver, lead and silver. Okay? All chloride salts are soluble except that of lead and silver. Okay? But lead chloride salts can be soluble in hot solutions or hot water. Okay? All chloride salts are soluble except that of what? Lead and silver. Are you following? Okay, nice. So also all trioxonitrate salts are soluble. So anywhere you see a trioxonitrate salt, that's NO3 salt, okay, they are soluble in aqueous solution. Nice. Also, all tetraoxosulfate salts are soluble except that of lead, barium, and calcium. Nice. So all tetraoxosulfate salts are soluble except that of lead, barium, and calcium. Okay. Also, all trioxocarbonates are insoluble. So all trioxocarbonate salts are insoluble. So those salts usually have CO3, okay, as a functional group in them. Okay, CO3. Okay, nice, nice. So all trioxocarbonate salts are insoluble except those of sodium, potassium, and also those of ammonium. Like I told you before, sodium, potassium, and ammonium salt, all of them are soluble. So sodium, potassium, and ammonium salts of carbonates, okay, are soluble. Others are now insoluble. Are you following? Nice. So you have to play with this table because if you can able to remember the soluble and insoluble salt, it's going to help you to answer correctly in case you see this in an MCQ questions in exam hall. Okay, nice. So some salts exhibit some peculiar features, okay, which can be efflorescence, okay, deliquescence, or hygroscopy. Okay, so these are some features used to describe some properties that salt tends to exhibit. Nice. So you can say that some salt can be efflorescent. Okay, some salts can be deliquescent. Okay, some salts can be hygroscopic. Okay, but before you say this now, okay, these salts must exhibit some known features. Okay, so we're talking about these features now. Okay, nice. So talking about efflorescence now, a salt is said to be a fluorescent, okay, when it can lose some water of crystallization. Okay, basically, salts combine with water to form hydrates. Okay, so these hydrates are called water of crystallization. Nice. So when some salts are left in the environment, they tend to lose this water of crystallization. Nice. So if this salt lose this water to the exterior, to the surrounding, okay, those salts are said to be efflorescent. Okay, but that property is called efflorescence. So an example of that is sodium tricarbonate decahydrate. Sodium tricarbonate decahydrate. Okay, so so this salt is a known efflorescent salt. Okay, because this salt can lose this water to the exterior. So when a salt loses water to the exterior, is called efflorescence. And that salt is now said to be what? Efflorescent salt. Nice. So we're talking about deliquescence. Deliquescence, okay? These are salts that can absorb water from from the environment, and once they absorb this water from the environment, they can be able to form solution. Nice. So this is a salt, okay, and this salt absorbs water, okay, up to a limit that is enough to form a solution. So this salt gets water, absorbs water from the environment into itself, okay, and once this water enter into this salt form a solution, okay, a solution. Those salts are said to be what? The liquescent salts. The liquescent salt. Nice. So examples of this liquescent salt are silical gel. You have sodium hydroxide. Okay. You have calcium chloride. Okay. So these are known examples. So these salts, they tend to absorb water from the exterior to form a solution of itself. Nice. So lastly, we have hygroscopy. Hygroscopy. Okay, nice. So this hygroscopy, okay, is almost synonymous with the liquescence. But what happens here is that the salt absorbs moisture. Okay, the salt absorbs moisture from the exterior. Okay, and unlike the liquescent salts, they tend to absorb water to form solution. But this salt basically absorbs what? Moisture from the exterior. Nice. So example of these hygroscopic salts are quicklime, sodium triazonitrate, copper 2 oxide. So quicklime, sodium triazonitrate, and copper 2 oxide are known examples of these hygroscopic salts. Okay, so these are the hygroscopic salts. So salts that exhibit hygroscopy and deliquescence, okay, are used as drying agents in the laboratory. Okay, so this is another salient exam question. Okay, so because basically they will list some salts in the questions, okay, in the option box. So the drying agents, okay, must either belong to the liquescent salt or hygroscopic salt. That's a wrap, guys. So, but before we leave for today, we'll answer some live past questions to assess what we have learned for the day. Okay, and mind you that these past questions, they are coined from past JAMB and tertiary institution questions. Okay, so make sure to attempt this. Okay, nice. So, guys, our number one question is: which of the following salts cannot be prepared by double decomposition reaction? Which of the following salts cannot be prepared by a double decomposition reaction? So A, I have barium carbonate. I have B, lead chloride. I have C, potassium chloride. I have D, silver chloride. So which of these salts cannot be prepared by double decomposition? Okay, so first of all, you ask yourself, double decomposition is used to produce which kind of salt? Okay, it is used to produce insoluble salts. Nice. So if you come here, so you're looking for the soluble salts here, because double decomposition is used to produce insoluble salts. Nice. So you know that soluble salts are salts of potassium, sodium, and what? Ammonium salt. Okay, nice. But here you have potassium salt here. So this is soluble salt. Okay, so these are insoluble salt, insoluble salt, insoluble salt. So our answer is potassium chloride. Okay, potassium chloride. So our next question is alums are dash. Alums are dash. Acidic salt, basic salt, double salt, complex salt. Acidic salt, basic salt, double salt, or complex salt. So alums are double salts, okay, which is used in treatment of water plants. Nice. So that's a wrap, guys. If you have any question of any type, let me know in the comment section and I'll get back to you. Okay, if you are confused on any topic on chemistry or this topic I've done today, let us know. I will get back to you as soon as possible. Please make sure you like this video, subscribe to this channel, and also share this video with your friends. For now, cheers.